Imagine a celestial object unlike anything we've ever seen hurtling through the vast void of space at 3 times the speed of the average comet in our solar system. This isn't a figment of science fiction, but a mysterious visitor entering our solar system in 2017. This unique object is the first interstellar object ever discovered in our solar system, named Oumuamua in Hawaiian, meaning a messenger from afar who arrived first. It has puzzled astronomers and spawned theories ranging from it being just an asteroid to possibly an alien spacecraft cruising through our cosmic neighborhood. Oumuamua was 15 million miles from Earth, about 62 times the distance from Earth to the Moon. What baffled scientists was its speed. As it revolved around the Sun, its rate increased, contradicting the laws of celestial mechanics. Could it be propelled by some unknown form of cosmic radiation, or is it a comet emitting gases in a way we've never observed before? In a universe governed by laws and equations, Oumuamua is an unsolved equation, a cosmic enigma in the shape of a rock. On October 19, 2017, a telescope in Hawaii picked up a faint flicker. This was no ordinary celestial body. It was Oumuamua, the first known interstellar object to visit our solar system. Unlike asteroids and comets born under the gravity of our Sun, Oumuamua was a wanderer from deep in interstellar space. Its trajectory indicated that it was not bound by the Sun's gravity, making it a transient visitor to our system. What sets Oumuamua apart is not only its origin, but also its special characteristics. Its elongated cigar shape, its rapid rotation. They don't fit the norms of typical objects in the solar system. The scientific community is buzzing with theories and debates about the nature of Oumuamua. Is it a comet without a tail, as destroyed with an unusual rotation, or something completely different? These questions have sparked rigorous scientific research, leading to a variety of hypotheses, from it being a fragment of a larger celestial body to even more speculative ideas such as it being an alien probe. The discovery of Oumuamua is a milestone in astronomy, similar to when people first looked through a telescope and realized that the Earth is not the center of the universe. It sheds light on the formation of the solar system and reminds us that our solar system is only a tiny part of a vast unexplored frontier. As Oumuamua moves farther away, becoming a faint speck in the cosmic sea, the need to study it grows. Hopefully, in the future, more advanced telescopes will capture more information about these interstellar messengers, offering new clues about the composition and history of the universe. Further analysis of Oumuamua reveals fascinating details. Originally classified as a comet, it had none of the typical cometary features such as a luminous coma or tail. It was for this reason that it was reclassified as an asteroid. However, it is not just any asteroid. It is an elongated cigar-shaped object unlike any asteroid we've seen before. Its unique shape has led to various speculations, including the possibility that it's an alien spacecraft. Scientific papers describe the physical characteristics of Oumuamua in more detail. They mention the object is tumbling rather than spinning, which is unusual for both asteroids and comets. This tumbling motion could be the result of a collision with another planet, but this state is purely speculative at this point. The trajectory of Oumuamua presents another intrigue. It entered our solar system at an unusually high speed and traveled on a hyperbolic trajectory, which in turn means it will never return. Most objects captured by a star's gravity go into an elliptical orbit, but not Oumuamua. According to scientists' assumptions, its trajectory was influenced by non-gravitational forces, which can be explained by the release of materials due to rapid vaporization. However, no such gas releases were visually observed, which further adds to the mystery. The lack of a visible coma and the object's high speed have led to various theories. Each detail uncovered about Oumuamua adds to the puzzle, prompting further investigation and speculation within the scientific community. Some scientists suggest it could be a fragment of a larger object that crashed, while others believe it could be a new class of object rather than a comet or an asteroid. Some even discuss the possibility that Oumuamua is a solar sail driven by radiation pressure. It's also believed that the object's high speed could make it a messenger from another star system, perhaps ejected by a planetary system forming around a young star. This could make Oumuamua one of the first observed interstellar objects, a relic from another part of the galaxy. The story of Oumuamua is a space detective story where each clue only deepens the mystery. Its elongated shape is unlike anything we've seen in the solar system. Could this unique form factor offer benefits for interstellar travel, such as reducing drag or increasing stability, or is it the result of some catastrophic event that we cannot yet fathom? Its trajectory adds another layer to the mystery. The absence of a visible coma and tail rules out the possibility that outgassing influenced its path. So what non-gravitational forces are at work here? Could it be affected by dark matter or some other unknown cosmic phenomenon? The theories surrounding Oumuamua range from the plausible to the fantastic. Could Oumuamua be a harbinger, a messenger from another star system? The possibility that it's a solar sail is particularly intriguing, and if proven, it could revolutionize our understanding of space travel, opening up the possibility of radiation-propelled voyages between stars. When it comes to investigating celestial objects like Oumuamua, astronomers rely on a variety of tools. The investigation into the nature of Oumuamua was led by a team of researchers that included Jennifer Bergner, a chemist at the University of California, Berkeley. Bergner and her colleague Darrell Seligman, an astronomer at Cornell University, were at the forefront of unraveling the object's mysteries. Their work, published in the journal Nature, is considered the most convincing model of Oumuamua's account. According to Marco Melli, an astronomer at the European Space Agency, the team's observations were supported by NASA's Hubble and Spitzer telescopes, which found that Oumuamua had a strangely elongated cigar-like shape and accelerated slightly as it left the solar system. This acceleration is commonly seen in comets when they're repelled by the material they emit. However, Oumuamua showed no such ejection or any visible coma of dust and gas, which we would expect of a comet. The team used modeling to show that Oumuamua could have originated as a normal water comet orbiting a nearby star before being ejected outside the system. High-energy cosmic rays could have converted up to 30% of the comet's water ice into hydrogen, which could have been trapped in Oumuamua's ice as it traveled through interstellar space. As it approached the Sun, the trapped hydrogen should have been released, giving the object the increase in velocity. According to Seligman, the team's theory explains every strange aspect of Oumuamua. It suggests that Oumuamua was indeed a comet-orbited, an unusual one. The lack of a visible coma or tail can be explained by the fact that molecular hydrogen is much less massive than the materials ejected by typical comets and therefore does not entrain much dust. While Bergner and Seligman's theory is convincing, it's worth noting that not everyone in the scientific community is convinced. Karen Meach, an astronomer at the University of Hawaii at Manoa, still believes that the conventional model of a comet could have occurred. She suggests that Oumuamua could simply have a small amount of dust, which would also explain the lack of a visible coma or tail. Another theory, the idea that Oumuamua could be an alien probe, has captured the public's imagination. Its elongated cigar shape and unusual trajectory led to speculation that it could be an artificial object. This theory gained traction when Avi Loeb, an astrophysicist at Harvard, suggested that Oumuamua could be a thin, flat, almost rectangular piece of material that could be a probe sent by an advanced civilization. Loeb's theory was widely reported in the media, fueling speculation. However, the alien probe theory made headlines. It has not stood up to scientific criticism. First, if Oumuamua was a probe, it would likely have emitted some form of radiation or signals that have not been detected. Secondly, its tumbling motion is not consistent with what one would expect from a probe designed to move steadily or collect data. Moreover, the object's trajectory can be explained by natural phenomena, as discussed in the previous chapter. The theory proposed by Jennifer Bergner and Darrell Seligman, which suggests that Oumuamua is a hydrogen-rich comet, explains its unique characteristics and does not require extraterrestrial intervention. The idea that Oumuamua could be an alien probe reflects our collective fascination with the unknown and the possibility of intelligent life beyond Earth. However, it also serves as a cautionary tale about the importance of rigorous scientific research. Speculative theories, while interesting, can divert attention away from a more plausible explanation. Although Oumuamua's unique characteristics have puzzled astronomers, the most plausible explanation is that it is an exotic type of comet or asteroid. Its long journey through interstellar space probably altered its composition, forming a crust that held most of the frozen gas inside. This theory explains the unique characteristics and is supported by observations by NASA's Spitzer Space Telescope. The discovery of Oumuamua has important implications for our understanding of interstellar objects. It suggests that trillions of such objects may be passing through our solar system, and we've only just begun to detect them. The Large Synoptic Survey Telescope in Chile is expected to receive its first engineering camera light in December 2023, with full-fledged survey operations scheduled to begin in October 2024. Once operational, LSST will potentially be able to detect more objects such as Oumuamua. It is planned that LSST data will be fully publicly available in 2 years, opening up new possibilities for understanding these enigmatic interstellar visitors. Beyond telescopes, advances in propulsion technology and data analysis may allow us to intercept and study these objects more closely. Imagine a future where we could send a probe to rendezvous with an interstellar object, collect samples, and send back data in real time. Construction of the European Comet Interceptor mission was recently approved. The European Comet Interceptor mission represents a significant leap in our ability to study interstellar objects like Oumuamua. Unlike previous missions that were designed to study objects inside our solar system, the Comet Interceptor is specifically designed to collect data on objects from outside it. The mission is led by ESA, with support from the Japanese space agency JAXA. The project aims to scrutinize a comet that has spent little time in the inner solar system and may be visiting for the first time. The spacecraft will consist of a main unit and 2 probes designed to observe the comet from different angles and create a 3-dimensional profile of its yet-to-be-discovered target. The mission is expected to be launched in 2029 and will travel to space with ESA's aerial exoplanet mission. Once in space, the Comet Interceptor will wait for a suitable target at the point of the L2 Lagrange, a location 15 million km behind Earth when viewed from the Sun, waiting for the next interstellar object to pass through our solar system. Once such an object is detected, the spacecraft will adjust its trajectory to make a close flyby, capturing high-resolution images and collecting data on its composition, structure, and even origin. The discovery of Oumuamua opened a new chapter in astronomy. How common are such hydrogen-rich objects in the universe? Could there be other interstellar objects with different compositions and behaviors? And most importantly, how can we prepare to better study these objects in the future? Oumuamua has served as a harbinger of future discoveries, encouraging us to prepare for new interstellar visitors that may be just as mysterious, if not more so.